Cybersecurity has become one of the key concerns for many in our virtual world, especially regarding cybersecurity for personal and privacy rights. There's technically no completely safe wireless. There are so many ways to hack a Wi Fi network that needs to be a main concern with data transmission. The best security currently is AES, or Advanced Encryption Service Encryption, with the latest wireless protocols. You're more likely to get hacked in a public Wi Fi than private, but all wireless traffic should be suspect. And this is due to spoofing gateways by using man in the middle attacks, wireless sniffers, and more. Wireless antenna dampeners can help keep from getting hacked outside your office from war drivers. Even when we're connected to the internet, many users commonly experience unstable or slow connection speeds with their wireless connections. This is especially severe in areas where multiple access points are installed. Signal interference is one of the reasons for the unstable connections. Interference can be the result of equipment coupled with different electromagnetic waves. Wireless dead spots are also an issue due to many thick walls and multiple stories. These can all be mitigated by using heat maps and centralized wireless. Heat maps tell you where there's going to be dead spots or too many Wi Fi signals that can cause crosstalk. Many higher end products like Cisco and Aruba support this type of technology. There are also handheld tools to detect signal interference that are on the market. One of the greatest challenges in managing a wireless connection is ensuring that every user within that environment is content with their connection speed and usability. Some users will download huge files such as movies and podcasts, while others barely use wireless at all. And this can be mitigated by setting up quality of service so no user can utilize over a certain amount of bandwidth. Additional access points running on separate channels in the high use areas can also help. Check that each wireless access point has the correct channel that they're going to broadcast on so they don't overlap with other nearby access points. Channel overlap can happen when you're not truly on an individual channel. Many of the channels overlap with other channels. There's more channels with 5 gigahertz than there are with 2.4 gigahertz, but check with your vendor to make sure that you're not using channels that may overlap with others in the area. There are many different Wi-Fi standards such as 802.11, ABGN, AC, and AX. What needs to be done is to find out what users' devices are capable with your wireless access points. If you no longer need N or below, then you can get better speeds by eliminating those protocols with your SSID options. The more protocols going through your antennas, the slower things will be, especially at the 2.4 gigahertz range. Try to stay only with 5 gigahertz when possible. Otherwise, ask management to upgrade your equipment. Many wireless problems can appear in your network, but all of them are resolvable by utilizing troubleshooting tools and the latest wireless equipment. There's many different devices that can cause Wi-Fi interference that you should be aware of. Many appliances such as microwaves and fluorescent lights, there are power cables and adapters, they all emit signals that can interfere with Wi-Fi. The best thing to do would be to switch to 5 gigahertz Wi-Fi instead of 2.4 to get better signal strength. Wireless devices, including wireless headsets, keyboards, mice, cordless phones, baby monitors, and other wireless devices can also cause problems with Wi-Fi. Gadgets commonly used, such as video game controllers, wireless security cameras, radio motion detectors, and others, can also have issues. 5 gigahertz, once again, can help with these types of interferences. If you live in an area with dense populations, such as apartment buildings, then the growth in Wi Fi network density, especially in populated areas, has increased among wireless networks. And that can cause all types of interference. Strong Wi Fi signals in close proximity to each other can reduce performance of both networks that are wired as well as wireless because of shared network connections. And new public Wi Fi networks are adding to this type of interference. Dampener antennas can keep those signals from entering your space and can be placed safely on the outside of a building or inside pointing out. Thick materials such as concrete, metal, and stone are not good for wireless signals. Reflective surfaces such as mirrors and foil found in modern housing insulation can cause erratic Wi-Fi signals. Adding more wireless access points can usually fix the problem. Many people don't know this, but Wi Fi works on line of sight. So if a computer's wireless network interface card and wireless access point can't see each other, then they have to rely on bouncing signals off floors, walls, and ceilings to get to each other. The more hops and the duller the material, the more the wireless will slow down. Placing devices in areas that have better line of sight are the way to go. Signal interference is a big part of troubleshooting your network, and this will become increasingly difficult as more Wi Fi capable devices enter your network.